So Thomas and I are the two members of the user. We formed in 1997. We're based in Montreal, and our projects began with sort of an inquiry into obsolescence as a case study for changing relationships between technologies and the people who use them.
And I should say before that the user is numbered. So this is user 1, and because we're of course numbered binary system, after the binary system I am user 0. So our background is, mine is in architecture, and I'm also an installation artist, and Emmanuel has background in composition, in electronic music, and I guess you're also an installation artist.
Indeed.
Yes, we are both installation artists.
So an early piece that we worked on about 15 years ago now involved appropriating an environment, the technological environment of a late 1990s office, and essentially the piece is called Symphony for Dot Matrix Printers, and it consists of assembling a very plausible set of technological equipment, namely a bunch of PCs and printers and the network technology that's needed to get them to communicate. But what we do is we repurpose these instruments and cause them to do something other than their usual purpose. So instead of being engaged in office work, what they're doing is they're making music. So they're reading from a collection of ASCII text files that we've composed in advance, and that we've composed very deliberately to musical effect. So we're using alphanumeric characters and other ASCII characters to generate sounds. And the work stems from a careful listening to what printers sound like and the kinds of sounds that you can get out of them when you cease to print functional texts, literary or otherwise sort of utilitarian text, and instead just work with the sound that is produced when you print a text. And it gradually evolves into a musical piece. So the first iterations of the piece were performances, symphonies number 1 and 2 for dot matrix printers. This is symphony number 2. There's, you don't see them here, but there are, in addition to the machines themselves, there are microphones that are amplifying the sound, and there are also cameras that are fitted into the mechanisms and to create close-ups that an audience can see so that you can establish a link between the movements of the printers and the sounds that result. We then went on to make a couple of installation versions of the work. This is called the Office Suite. It premiered in 2002 at a gallery in Pittsburgh. And the next one is called Quartet for Dot Matrix Printers, which was shown first in Dortmund in 2004 and has been played in a number of venues since then. We've got a little clip from Quartet for Dot Matrix Printers that explains the That is Symphony for Dot Matrix Printers. The next project we worked on together is called Xylophone. Thomas is going to talk about that.
So Xylophone is a project that came out of my thesis work at university, and it involves the silo number 5 grain elevator in Montreal, which is a grain transposition facility, storage and transposition facility, which was used to house grain that was grown in the prairies temporarily before it was put onto cargo vessels bound for mostly for Europe and the European market. And it was abandoned in 1995 and is a source of inspiration and fascination and obsession for the architectural community in Montreal because it's right downtown, and this is actually the last of the great silos that are left. Silo number 5, there are of course 1 through 4 and even 6, I think. And this is the last one which exists downtown in the city. The others have been demolished. So we got inside the building and started exploring it and discovered that there is a fantastic acoustic in the inside of the buildings, inside these cylinders, which are 100 feet high by 25 feet wide. Which comprise which make up the structure of the storage facility. So rather than recording music inside these fantastic spaces, which are sort of on par with the Taj Mahal and St. Paul's Cathedral in terms of their resonance time, we decided that the most interesting thing that we could do with these things was actually to share the space with the outside world, because you're not allowed to go into the building. Normally it's too complicated for insurance reasons and all the rest of that stuff. So what we did was we transformed the building itself into a public instrument to which you can send sounds either by telephone or by the internet or by through the use of this installation that we built in front of the building. So you speak into a microphone in this installation, your voice is broadcast inside the chamber, it resonates, is transformed, and comes back to you over the loudspeakers here, or is streamed back to you over the web or via the telephone, and you can hear the result of your sort of test of this acoustic environment at a distance without actually going inside the building. So this project still exists. It's a bit rickety at the moment. The technology dates back to 2000, and web projects don't usually last more than 6 months, and this one has been going since 1999. So we'll move on to more recent projects, which the series, one of which we're presenting here. This is an homage to György Ligeti, the Hungarian composer who died in 2006. And he was one of the main references for the dot matrix printer symphony that we created, because he was one of the first to actually treat sounds in a concrete fashion, sort of non-musical sounds, and use them for musical ends. And his piece, Poème Symphonique, is a composition for 100 metronomes, which are on stage. And you want to talk about that?
This is a staging of the work that we did in The Hague a few years ago. The 100 metronomes are set to different speeds. They're all set going, and the piece is over when the last metronome has ceased to tick because the spring is wound down. So our version, our homage to this piece, involves the clocks that you probably noticed on your way in. There are about 1,200 of them, and it's a very similar concept. We set them all to exactly the same time, and then they just tick. And the piece is nominally over when the last clock has run out of batteries. Unfortunately, we haven't actually staged a version of the work that lasts that long. It usually takes about 10 months, depending on the strength of your battery. So, I mean, we won't talk about this piece too much. You can experience it for yourself. But Coincidence Engines is actually a series. So the one outside is Coincidence Engine 1. And here are a few images of Coincidence Engine 2, which is a composition for the same clocks to begin with. They've been electronically modified so that rather than ticking of their own accord, they tick on command. So they don't listen to their internal quartz crystal. They respond to a signal that is sent by a sort of pretty elaborate electronic system that essentially exists as a support for a composition, an audio-visual composition. Short excerpt of that video here. and for that piece, we return to Ligeti's metronomes, actually. But here again, they're electronically modified so that they can do things like change the height of the adjustable weight without anybody touching them. There's a little motor that enables that. And there are also sensors, audio sensors, that allow the metronome to allow this little microcontroller brain to know what the tempo of the metronome is at any given time, as well as the tempo of the metronome's neighbors. So basically, it's like a distributed intelligence of these little metronomes that listen to one another and arrive at consensus, rhythmic consensus, if you will. This is some shots of the assembly of the work, and a short sort of proof of concept prototype. So here they're set off, and they're obviously running all of the within a relatively short time to achieve synchronization, but it's possible to instruct the metronome not necessarily to arrive at perfect sync, but to strive for sort of more complex simple rhythmic ratios to get these things to jam together.
And then a very quick run through of one of the last projects that we worked on, which is a very different kind of project. This is called Portrait Landscape Machine, and it is consists of a giant three-dimensional printer, back to the printers, but this time one that we fabricated ourselves. So it's a 3D printer that prints in Russian constructive manner only. No, that's not true. It prints in sand, using water as the only binder, so that we can actually reproduce a sort of sandcastle version of portraits of the public. It's conceived as a public artwork. So this was one of the initial tests that we made. And this person's name is Frank. We never met Frank, but we got Frank's face in 3D scan to before 3D scanning was really easy to get your hands on, and then we printed Frank in sand, and this is Frank.
Scale. The scale of the work is about 2 foot by 4 foot or something like that.
Thank you very much.